All right, ladies and gents, so today we are going to talk about finding the area of regular polygons. So if you remember back to when we first started talking about polygons, regular ones have the same sides, so all the sides are going to be congruent, and all of the angles are going to be congruent. Now, there's two additional vocabulary words that I want you to know about regular polygons. There's something called the apothem, and the apothem is going to be the distance from the center of the polygon to any side. So when you're looking at the right figure, or the figure to your right, the apothem is going to be that little piece right there. Because remember, the shortest distance is normally what we talk about when we say distance, and the shortest distance always creates a perpendicular angle with whatever you're walking to. Like I always tell you, that's why crosswalks are normally perpendicular to the road, because they don't want you in the road for very long. The other vocabulary word is the radius. Now, we've heard about the radius with circles. The radius, when you're talking about a regular polygon, is going to be from the distance from the center of the polygon to a vertex. And so I labeled that over to the right. Now, here is the golden ticket for today. This is the area formula, where area is going to be 1/2 of A times P. Couple things. The little a represents apothem, and the capital A is going to represent your area. Some people were getting a little confused about that. So the little a is that apothem that we've talked about, and then that little p actually represents the perimeter. Okay, so if you look, let's start off with some basic problems actually. So in number 1, if I asked you to find the area of each regular polygon, the first thing that you would want to do is to find your apothem, and you want to find your perimeter. So the apothem is given to us. It's that 7 feet right there. The perimeter we can easily find because we know that one side of this regular polygon is 24.2 feet. And because it's regular, so are the other two. So all I'm going to do is take 24.2 and I'll multiply it by 3. And that'll give me my perimeter, which is going to be 72.6. Now, once I have both of those pieces of information for my formula, I just take them and plug them in to the 1/2 times the apothem times the perimeter, which is going to be 1/2 times 7 times 72.6. And so that will give me the answer of 254.1, and the units are square feet. All right, let's do it one more time with a simple one. So if we're looking at number 2, again, for our area formula, we need to know the apothem, and we need to know the perimeter. The apothem is given to us. It's at 16 centimeters. And the perimeter we can find, this time we're going to take that 13.3 for the one side and multiply it by 8 because that's an octagon. And so that will give us 106.4. All right, and so then we just take all that information and plug it into our area formula. So 1/2 times the apothem times the perimeter, which will end up being 851.2 square centimeters. Hopefully you don't have any questions at this point, and if you do, you can just come back and let me know tomorrow and I'll answer them for you. But we're going to spice these problems up quite a bit. So what happens if I don't give you the apothem or I don't give you a side length? How in the world are you going to find the area of these regular polygons? First things first, you are going to find a right triangle by drawing the apothem and the radius. Second thing that you will end up doing is you're going to find the measure of the interior angle to that right triangle. And we'll talk about that. There's some more information afterwards. But I think you'll learn better when we go through the problem. And then the third thing that you're going to do is you're actually going to use trigonometry. Now I skipped over this piece, the special right triangles, because I think that as a class, we were better at using trig. If you want to try using special right triangles, which it was like the 2a, a root 3, and a jazz that we did in class, you may feel free to go through that, but I'm going to do those 3 steps. I'm going to use a right triangle. I'm going to find the measure of one of the angles inside that triangle, and then I'm going to use the trig. So let's get to it. So if you're looking at number 3, I see that I have my apothem, but I do not have my perimeter for my formula. So I need to find the formula. Here's what I'm going to do. I'm going to do step 1, where I create a right triangle by drawing the apothem. It's already there. And then I'm going to draw one of the radiuses. That right triangle, if I can find this side length right here, then I'll be golden. I'll be able to find the perimeter, which is what I need for my formula. So how do I do that? Well, first things first, if I want to use trigonometry, what I have to do is I need to know one of the angles in there. And you're probably saying, Miss Clark, but you know the 90-degree angle. Yeah, that's right. That 90-degree angle allows me to use trigonometry. I need to know one of the other angles. I either need to know this one or I need to know that one. I'm going to choose to solve for this one. And here's how I'm going to do it. First things first, I'm going to use that sum formula that we learned a while ago, where the sum of all the interior angles is going to be 180 times the quantity of the number of sides minus 2. Well, I know the number of sides in here is 6. So all of the interior angles inside of that hexagon are going to measure to 720 degrees. Now, I also know, since this is a regular hexagon, that all the angles inside of this hexagon are congruent. So I can take that 720 degrees and share it evenly amongst the 6 angles and find out that one angle is 120 degrees. Now, that helps me actually find what this angle is. If each angle is 120 degrees, that radius is going to bisect the angle, making that interior angle 60 degrees. And now that I know that that's 60 degrees, I can use my trigonometry to help me find my x value. So if I'm looking at the 60-degree angle, this x is going to be my adjacent leg, and this 5 is going to be my opposite leg, which tells me to use tangent. Tangent of 60 degrees is going to equal the opposite, 5, over the adjacent, x. Now I go through and I solve this. First things first, First things first, I'm going to multiply both sides by x. Then I'm going to divide both sides by the tangent of 60. Now, please make sure that your calculators are in degree mode, and then tell me to the nearest hundredth, or figure out to the nearest hundredth, what is 5 divided by the tangent of 60? And that's going to be 2.89 approximately. Now, how does that help me? Well, ladies and gents, that tells me that this little piece right here is 2.89, which allows me to say that this piece right here is double that, or each side inside of that hexagon is going to be 5.78. Now, why is that useful? Remember what our end goal is here. Our end goal is to find the area of this thing. And so we need to use the area equals 1/2 times the apothem times the perimeter. That 5.78, I take that and multiply it by 6 because I have 6 sides that are equal to 5.78. Which gives me 34.68. Now I have all the information I need for my area formula, where my area is going to equal 1/2 times the apothem, which I already know is 5, times the perimeter, which I just found out is 34.68. So that tells me that my area is approximately 86.7. Units would be squared meters. A lot. I know it's a lot. Let's do it again. So if we're looking at number 5, that's right, I'm jumping down there. Again, the first step, well, if you look, I know the apothem. I need to find the perimeter for my formula. So the first step I'm going to do is add in that radius. And I'm going to be looking for that x value right there. Second thing I need to do is find an interior angle inside of that right triangle in order to use trigonometry. Well, the sum of the interior angles of a pentagon is going to be 180 times the quantity of 5 minus 2, which is 540. So that means each of the angles inside of this pentagon, or pentagon, are going to equal, if I divide 540 by 5, 108. 108 degrees, which means that, oops, hold on, sorry. Which means that this angle right here is going to be 54 degrees. That angle right there is going to be 54 degrees. Now that I have an angle inside of my right triangle, I can use trigonometry to help me find that x value. So again, that 10 is the opposite leg and that x is the adjacent leg. So that tells me use tangent. So the tangent of 54 is going to equal the opposite, 10, over the adjacent, which is x. And when you go through and you solve this, you're actually going to get that x is going to equal whatever 10 divided by the tangent of 54 is, which rounded to the nearest hundredth is going to be 7.27. Now that tells me that this little piece right here is 7.27. So that tells me a whole side inside of my triangle will be double that, which is 14.54. Again, keeping in mind what your end goal is here is to use the formula. So I need to use that piece of information to help me find the perimeter. The perimeter will be 14.54 times 5 this time, because there's 5 sides, which then is 72.7. Now I've got all the goods, and I can go through and use that area formula, where my apothem is 10, and my perimeter is 72.7. So my area is approximately 363.5, and your units are square inches. All right, so that's one type of problem. If you flip it over, we're going to see some other types, but we're going to do the exact same steps, so don't get worried. So let's go through 2 more problems and then we'll be done. So if you, oops, a little preview. If you are looking at number 7, what we're going to do is we need to find the area of this regular polygon again. However, this time we can easily find our perimeter. They tell us that one side in this pentagon is 8, so 8 times 5 is going to be 40. The problem here is that we actually need to know our apothem. That's the missing piece. So let's go through and actually find that. So just like before, the steps are that you want to draw your apothem and your radius to make a right triangle. And this is the goal that we're looking for. We're looking for that A. Nice little piece of information. You actually know that this side inside on the right triangle is actually 4, because 8 divided by 2 is 4. So the second step that we want to do is then to find an interior angle. Same as before, you know that the sum of a pentagon is going to be 540 degrees, or the sum of the interior angles in the pentagon will be 540. So that means that each angle inside of the pentagon is 108, making this angle right here half of that, 54 degrees. Next step is to then use trigonometry to find your missing piece. In this case, if we're looking at the 54 degrees, the A is going to be our opposite side, and that 4 is going to be our opposite leg, and the 4 is going to be our adjacent leg. So again, we're using tangent. Now, if you're one of those people who thinks that we are going to use tangent every single time, stay tuned, because that is not true. But anyways, tangent of 54 is going to be the opposite, which is A over 4. And so in this case, your A value is going to end up being 4 times the tangent of 54, which is approximately 5.51. Good news is you don't need to go any further in this case, because remember, your end goal is to use the area formula, which is A equals 1/2 times the apothem times the perimeter. We just found our apothem. It was 5.51. And we earlier found our perimeter. It was 40. So our area for this pentagon is going to be 110.2 square inches. So that's another type of problem. And then the last type of problem that I'm probably going to give you for these is a problem like number 11. So for number 11, now you don't know the apothem, because this is the radius, and you don't know a side length. So guess what? You have to find both. So go through the exact same steps that we were doing before. Draw your apothem and find the missing pieces that you need in that right triangle. Well, I need to know my apothem, and I also need to know this x value so I can find the perimeter. Now, second step was to find the interior angle. Side note, we don't have to do much work for that here, because we know all the angles in a square are already 90 degrees, so that makes this a 45-degree angle. And also, this one is going to also be a 45-degree angle. So a little hint, not only is this triangle in here right, it is also isosceles. So that means my x and my a value are going to equal each other. But anywho's, let's pretend that we didn't know that, and I'll show you how you can go about finding it otherwise. Let's just pretend that we didn't make that connection and that we only know this piece of information that's right here. What you would end up doing is doing trigonometry, not once, but you do it twice. And so what you would do is, so let's say we're finding our apothem, that would be the opposite leg and the hypotenuse. So again, like I said, stay tuned. We're not using tangent anymore. This one's going to be sine. So the sine of 45 degrees is going to equal opposite, which is A, over your hypotenuse, which is 3. So A will end up being 3 times the sine of 45, which is approximately 2.12. Okay, and so that's the A value. And again, like I said, we're going to pretend that we didn't know that it was this red triangle in there is a isosceles. Let's find our x value. So with the x value, that leg is the adjacent leg, and again, the 3 is your hypotenuse. So this time, instead of using sine, you would use cosine. So the cosine of 45 degrees is going to equal the adjacent, which is x, over your hypotenuse, which is 3. And so your x value is going to end up being 3 times the cosine of 45, which is then going to be, again, the same thing, 2.12. And so you go through and you are going to find the area by plugging it into your area formula. Oh, but we're not done yet because we need to find the perimeter of our square. So the apothem we already found was 2.12. And your perimeter would end up being a little bit different, keeping in mind that this piece right here is going to be 2.12. So a whole side is going to need to be 4.24, and you would end up having to multiply that by 4 because there's 4 sides of the square. And I just walked upstairs because my roommate came through the door and I didn't want you to hear her voice, but whatever that is, I think you could figure it out. You'd plug it in here and then you'd find your area. Alright, so that concludes this video. So go ahead and if you haven't already done so, try the right side of these notes and then bring them back tomorrow.